Hello there. We are going to continue on in Unit 8 talking about how logarithms and exponential functions are related. Okay, so I want you to think of these as inverse functions. Okay, so kind of similarly how if we had something like x squared and the square root of x, right? Those are inverse functions because a square undoes a square root and a square root undoes a square. Same type of thing with logs, okay? Notice just like with a square and a square root, they need to have the same power, the same index, right? If this is a square, then we have to use a square root. Or if we had something like x cubed, we could use a cube root, right? So the power and the index have to match with squares and square roots, cubes and cube roots. So the same thing is true with logarithmic functions and exponential functions. Whatever that base is of our exponential function also needs to match what our log base is. So by definition, if b to the y equals x, then y equals log base b of x. Okay, or similarly, if we have b to the x equals y, then x equals log base b of y. Okay, notice in both cases we have the same base. Okay, so it's very important to identify what the base of the exponential is so that we can figure out what the corresponding log base should be. Or if they give it to us in logarithmic form, we need to be able to identify that little subscript base so that we know what base to use in our exponential form. Okay, all right, so with that being said, I do want to point out two things. One, I am probably going to teach this section a lot differently than Knewton may teach it, so I am fine with you learning whatever is presented in Knewton if that's helpful. But I'm going to show you how to convert from exponential form to logarithmic form based on the strategy we're going to use later on when we get into logarithmic and exponential equations. Okay, so if what I do in class looks differently than what Knewton is presenting on and in their software, just be aware of that. Okay, neither one is incorrect. There's just different ways to approach these problems. Okay, all right, so that's the first thing. Second thing is we have two special logs. Okay, we'll call them special. The reason they're special is because they have buttons on our calculator. So these are our calculator buttons, which make our life easier. Anytime we have buttons on our calculator that represent something, it saves us a little bit of extra effort, right? So the log button on your calculator is actually our common log, okay? And it's common because most of the time we use base 10 when we talk about our numbering system, right? So if it's base 10, we just write it as log x. So instead of writing log base 10 of x, we write log x. Now, I will never count off for you writing log base 10 of x, but in Knewton, when they give you like multiple choice solutions to choose from, they will just write log x. So I want you to get familiar with anytime you see log without a subscript here, it's an implied base 10, okay? Similarly, with our ln button on our calculator refers to the natural log. And the natural log is when we're dealing with base e. Okay, e is a letter that's representative of that number 2.71, blah, blah, blah. It just keeps going, right? We use e's a lot as you get into your higher math and you start looking at applied problems, exponential growth and decay and things like that. We'll use e more and more. So it has its own special little log button here. And this is the equivalent of writing log base e of x. Okay, so anytime we're using log base e, we want to replace log base e and just write it as ln. Okay, this is not something that's super nitpicky, but it's kind of like writing a 1 in front of a term, right? If I had something like, you don't have to write this, but if I had something like x squared, right? It's the same thing as writing 1x squared. We know that the implied coefficient is a 1 without having to write it. Okay, so that's kind of like this. Without having to write the e on our base for our log, we just write ln and we know that that represents base e. Or if you see just log, we know that that represents base 10. So these are two things you do need to be familiar with because you'll see them more and more. Okay, so let's go ahead and look at how to rewrite an equation from exponential form into logarithmic form, or logarithmic form into exponential form. Okay, so we have one here at the bottom of our page. Let's see if I can move this wire. And we have a squared equals 15. Okay, so if I have a squared equals 15, the first thing that I want to do is identify what is the base, right? Because whatever the exponential base is, I want to use the log with the same base to help undo that exponential, so to speak. Okay, so here I can see the thing that I have with an exponent is a. A is my base. So I'm just going to say find base first. Okay, so now that we have identified what our base is, what we want to do is just like when we had an x squared and we identified, okay, we need a square root, we're going to apply that function to undo the squared function, right? We're going to apply the square root function to undo the squared function. So just like in this case, I have an a base exponential function, so I need to use a log base a function to undo that exponential base. Okay, so in other words, I'm going to take log base a, right, because they have to have the same bases, of a squared. And if I do that on the left hand side, I have to also do that on the right hand side. So all I'm doing is applying a log function to both sides of my equation. And it maintains equality as long as I do it to both sides. Okay. Now the reason I'm doing this is because my log base a function will undo my exponential base a function. Or in other words, those cancel each other out. So I'll be left with just a 2 equals log base a of 15. Okay, so this is an equivalent equation for this exponential equation. So all I did is go from writing in exponential form to writing it in logarithmic form. Okay, so I'm not solving, just rewriting it in a different form. Okay, finding something that is equivalent to. So let's look at it going in the opposite direction. I know it didn't ask us to do this, but let's say we start with this. What if we were given something in log form? How can we get back to our exponential form? So let's pretend just for a second that we're given 2 equals log base a of 15. Okay, maybe we're given the log version of it first. Same thing, we still want to identify what our base is. Okay, so find base first, or identify, maybe is a better way to say that. Identify what the base is first. So we can see here, all we have to do is look at that little subscript inside our log function to see what the base is. Here it's base a. So just like I did over here, I want to do the opposite operation, or the opposite function, the inverse function. So here, log base a undoes exponential base a. So if I have a log base a, I can then use exponential base a to undo it, right? So notice on this one, my exponential had to be inside of my log for that to cancel. Okay, it wouldn't have canceled if I had an a squared out front. Okay, the exponential had to be inside my log, or my log had to be evaluating it. Kind of the same thing as when we talk about our square and our square root, right? If I had x squared times the square root of something, these aren't going to cancel, right? I have to have that x squared inside the square root for those to cancel out, right? So the same thing is true here. If I want the log base a to cancel out, it's going to have to be inside the exponent of my exponential function. I have to plug it inside. Just like the a squared was inside the log base a, my log base a of 15 is going to have to be inside an exponential function. So what I'm going to do is I just identify what base I need, which here is a, and then I'm going to create an exponential equation by just taking my equation that I have here and moving it to the exponent. So this will give me a to the second power is equal to a to the log base a of 15 power. So because this equation is a true statement, I can take a true statement and move it to the exponent as long as I have the same base, right? Because if 2 equals this, then a to the 2 has to equal a to the this, right? Okay, so notice now my log base a is inside the exponential function base a. So again, those are going to cancel, and I'll just be left with a squared equals 15, which you can see is what we were initially given. Okay, so that's what I'm going to do on these next couple of pages is just work several examples. So they're either going to give it to you in exponential form, and you're going to use the log with the same base to undo it, or they're going to give it to you in log form, and you're going to use the exponential base to undo it. Okay, so let's go ahead and look at some on the next page here. All right, so on this one it says, if 10 to the third equals 1,000, which is equal to 3? Okay, so I'm going to just come over here to the side. 10 to the third equals 1,000. And I don't want to get confused by all the choices they're giving me, so I'm just going to ignore that. And I'm going to change this into a log form, right? Because obviously all my choices are with logs, so I know I need to get this out of exponential form. So the first thing I do is identify my base. So I look, the thing with the exponent is the 10. So if I want to get rid of exponential base 10, I'm going to use log base 10. So log base 10 of 10 cubed is equal to log base 10 of 1,000. Okay, if I do it on one side, I have to do it on the other side. So now that I have an exponential base 10 inside of my log base 10, those will cancel. And I'm left with 3 is equal to log base 10 of 1,000. Now, I would be fine with this on an exam, but notice none of these logs have a subscript. And that's because anytime our subscript is a 10, remember that's our common log. And anytime we have log base 10, we don't need to write the 10, we just write it as regular log. Okay, so this means that 3 is equal to log of 1,000. Okay, and now I don't mind if you use parentheses or if you don't. I've noticed on Knewton a lot of times they won't use parentheses. So if this is something you have to type in, I would probably type it in without parentheses just to make sure that you get the answer right, because I don't know if it'll count off. I like to use parentheses because I think it keeps it a little bit cleaner. All right, so obviously our correct answer is this third choice, log of 1,000. Okay, all right, let's look at another one. Here it says, using the definition of the logarithm, what expression should go in the blank? So you can see here that our 6 has come out of the exponent. The only way we can get that 6 out of the exponent is if we got rid of that exponential base. Okay, and it says we're using the definition of logarithm. So I'm going to change forms. I'm going to take 3 to the 6th equals 729, and I'm going to rewrite it as a logarithm. So notice here my base is 3. So that means if I want to get rid of exponential base 3, I need to use logarithmic base 3, right? So I'm going to do log base 3 of 3 to the 6th is equal to log base 3 of 729. And now that I have an exponential base 3 inside of a log base 3, those cancel, which gives me 6 is equal to log base 3 of 729. So when they give you a problem like this, since they already gave you the 6, you're only going to need to type in what that equals. So my answer for this would just be this piece right here. Okay, so I would type in log base 3 of 729. Okay. All right, let me look at a couple going the opposite direction. So here it says, given that log base 2 of 256 equals 8, write an exponential equation, okay? Write an equation. So that doesn't mean I'm going to use just a piece of it, right? I want the whole equation, which is going to be equal to 256. So I'm going to start off with log base 2 of 256 is equal to 8 and identify my base. I can see here that my base is 2. So that means I need an exponential base 2 to cancel out that log. Now I can't just multiply by 2 because that won't cancel the log. I need that log to be inside the exponential. So I need it to be up in the exponent of that 2 in order for it to cancel. But if I put an exponential base 2 here, I also have to put an exponential base 2 on the other side. Okay? So 2 and log base 2 will cancel, which leaves me with 256 is equal to 2 to the 8th power. So notice I want the whole equation. Here's my equation. Right. Let's look at another one. I think I have 2 more and then I'll let y'all do some. So this one says if log y equals 9, what is y equal to? So notice it's not asking me for the whole equation. It's just asking me what it equals. So I'm just going to put in whatever expression y is going to be equal to. So I start off with log of y equals 9. Now notice there's no little base. There's no little subscript written. So if there's no base here, this is a common log, which means that it is base 10. So if I want to get rid of a common log, I need to use an exponential base 10. Now, if this is just totally brand new to you and you're having a hard time with this, I would go ahead and write this as log base 10 of y is equal to 9. That way, once you see that little base number, you know what exponential number to use. So we're going to use a big exponential 10 and move our log equation up into the exponent. So 10 raised to the log base 10 of y equals 10 to the 9th. And now that my log base 10 and my exponential base 10 are inverses, those cancel and I get y is equal to 10 to the 9th power. So they asked me what is y equal to, so my solution would just be 10 to the 9th power. Okay? All right, let me look at one more and then I will have y'all try some. So on the next page, we have which exponential equation is equivalent to log base z of 9 equals 2. So it's asking me for an exponential equation, which means I need to change forms. I want to take it out of logarithmic form and change it into an exponential expression, right, or equation. So I'm going to go ahead and write log base z of 9 is equal to 2. Identify the log base, so my subscript here, which is a z, and I'm going to use the exponential form of that base. I'm going to use an exponential z and move my log inside of it. And it has to be inside the function. So z raised to the log base z of 9 is equal to z raised to the 2nd power. Okay, so my z raised to the log base z cancels, and I end up with 9 is equal to z squared. Notice I'm not solving this because I could solve this, right? Take the square root and get plus or minus 3, but I don't want to do that because I'm not solving. I'm just writing an equivalent equation. So now that I have my equivalent equation, I just see which of the choices here match it, which should be this 3rd one, right? Z squared equals 9. All right, so there are 4 practice problems for you to try, 2 on this page and 2 on the next page. Go ahead and pause the video and try those out, and then whenever you're ready, unpause the video and we'll go over them. All right, so on number 1, we are trying to remove a log, right, so that we can write this in exponential form. Now there's no subscript written here, so that's an implied 10. So log base 10 of x equals 7. We use a big exponential base 10 to cancel that out, but if we do that on the left, we must also do that on the right. So that leaves us with x is equal to 10 to the 7th power. Okay, not too bad maybe. Let's look at number 2. Number 2, we have 3 to the 4th power equals 81. I can see here that my base is 3. So I want to use log base 3 on both sides. So log base 3 of 3 to the 4th equals log base 3 of 81. and my log base 3 and 3 will cancel. So I end up with 4 is equal to log base 3 of 81. So if they give you a line to enter your answer, be sure when you enter your answer, you're not writing 4 equals. Okay, only enter the piece that's missing from what they gave you. Okay, all right, let's go ahead and look at number 3. Number 3 is relatively easy. We have e to the 5th power equals w. Now to get rid of a base e, we want to use logarithmic base e, right? So log base e of e to the 5th equals log base e of w. Log base e and e cancel, so that leaves me with a 5. And then remember, log base e was one of those special logs that we went over at the beginning of this section, right? Log base e is the same as ln. So we're going to go ahead and just write this as 5 is equal to ln, or the natural log of w. Okay? All right, and then our last one, number 4, we start out with log base 2 of 6 equals a. We need to get rid of log base 2. So we use exponential base 2 and plug our equation into that exponential function. So 2 raised to the log base 2 of 6 equals 2 raised to the a. My 2 and my log base 2 are going to cancel, which leaves me with just 6 is equal to 2 to the a power, which is my first choice on my solutions. Okay, so that is the end of Relate Logarithms and Exponents. So you should now be able to complete that homework assignment. If you have any questions, please let me know.